Welcome, y'all. We're starting chapter 10. We're talking about circles and circumference. This whole chapter will be based around circles and parts of circles. So let's kind of go over our first part. So, a little definition again: a circle is a set of points, all equal distance from that one given point. That one given point being the center. So, for example, here, there's our center. All these points that are all the same distance away from the center is what creates a circle. So the circle is not a line, because line is straight, y'all. Remember, lines are straight. These are not circles. These are all points that are so close together that you look at they're all touching like that. Which they kind of are in this case. Now, a radius, or radii for plural, is the distance from that center point to a point on the circle. So there's in the circle, out the circle, and then on the circle. So understand, there's a difference between saying, hey, we're inside the circle, we're outside the circle, we're on the circle. On the circle means all these points right here. Okay, that center point, again, is your center, as we just said. So, little definitions here. Now, let's talk about other parts that we will see throughout this chapter. Now, a chord is a segment, means a starting point and ending point. This is a chord. It starts on the circle and ends on the circle. So this is a chord. Oh, it's an R. Chord. Now, a diameter is a special chord. It is a type of chord in which it starts on the circle and ends on the circle. But the defining point is it goes through the center point. It goes through the center. That's what makes it different than just a regular chord. So here's a diameter right here. Diameter. Right now, a tangent line, very similar to a chord where it goes through the circle at 2 points, but it keeps going. Unlike this, these are segments, meaning they stop. Starting point, end point. Tangent is the line. That means it goes through the circle and it touches twice. Now, there can be a tangent line that goes through here as long as these keep going out. So there could be a tangent line here. But here's a definition. This is a visual representation of that. A tangent line. Oh, that's a lie. My bad. This is a tangent line. Tangent. It touches a tangent. Man, I don't even know how to spell tangent today, y'all. It's Friday. That's what it is. Tangent line means it touches the circle once at the point of tangency. As it says right here, point of tangency. This point G right here is the point of tangency. Tangency. This right here, this one that goes through it, is a secant line. A secant line, similar to a chord where it touches it twice. Undo that real quick. Okay. Touches it twice, and it keeps going. So it's a line. As it says, a secant is a line that intersects a circle at 2 points. So this is a secant right here. Secant. And the tangent touches the circle once. Similar to a secant, it's a line. So there's chords and diameters. They are segments. They start and end, start and end. And then there's secant and tangent. They're lines that keep going. For a secant, hits the circle twice. For a tangent, hits the circle once. All right. That being said, look at concentric circles. So concentric circles are circles that all have the same center. So here we have 1, 2, 3, 4 circles that all have the same center. The most popular kind of concentric circles is a bullseye. We think of a bullseye when we're talking about concentric circle. That's the most popular one. There's a bunch of circles in a bullseye, or even in darts. There's little targets. Even though they have those little weird rectangles all the way around sometimes, they're all concentric, all around one thing, the same center. Now, inscribed polygons are shapes, for example, this rectangle and this triangle, that are inside the circle, and their vertices touch the circle. So if it's a square, it has 4 vertices, or some sort of quadrilateral has 4 vertices, so it has 4 point of intersections. If it's a triangle, 3 vertices, 3 point of intersections. Now, circumscribed polygons is a shape that goes around the circle. So this is the circumscribed polygon. It goes around the circle. And unlike this right here, these points do not touch the circle. They do not. The vertices do not touch. But each side is tangent. That means each side of the polygon touches the circle at one spot. Right there and right there. It touches just at one spot. So inscribed, meaning they're drawn inside, the vertices touch. Circumscribed means you draw it outside and it touches on the sides of that shape. So this is a quadrilateral, four-sided, so it should be 4 points of tangencies. If it was a triangle of some sort, say something like bam, bam, and some weird bam. That's a horrible triangle. But triangle at least, it touches it at 3 spots. There we go. 3 spots. So circumscribed and scribed. All right. Last thing on this right here, circumference and pi. Now, circumference is the distance around the circle. And to find circumference, as we've done before, circumference equals 2 times pi times radius. Okay. Pi is the ratio of circumference over distance of a circle. So the distance around the circle, pi is circumference over the distance of the diameter. So to figure out pi, here's the thing, pi is an irrational number because the points never stop or end. Now, pi can be found by taking the circumference. Pi will always equal the circumference divided by the diameter every single time. Every single time. That's why the diameter and the circumference have a relation to each other. 2 pi, 2r is diameter. Diameter. So diameter. So circumference can be written as diameter times pi. Check this out, y'all. Check this out. We're about to do some magic here. So, and as it says, if we were to divide this by diameter, what does we have over here? We have pi equals the circumference divided by the diameter. Look at that every single time. So 3.1415, so on and so forth. That ratio is always equal to the circumference divided by diameter. Now, earlier this year, we kind of talked about this, and we showed a video how they took the diameter. They take the diameter, and then they just wrap it around the circle. And they realize it goes 1, 2, 3, and then this little part right here, that little part that it doesn't go, is 0.14159 ... That's why pi equals 3.14159 ... so on and so forth. That number has measured out to 10 billion numbers from now. That's how that little part right there is probably the most important part of this whole thing. The most accurate. That's what makes it very unique. But this is just over circles. Now, there's no assignment for 10.1. Let me double check. But this is a little video to kind of give you an introduction. This is very important information, especially this part. So make sure you definitely review this and kind of really focus on this. Now remember, segments, the endpoints, they have start and stops. Lines do not. They go forever and ever in opposite directions. Okay? All right, y'all. Hopefully that helps. Bye.